Step 2, we take the x-intercepts and turn them into factors. So 2 and negative 3 turn into x minus 2 and x plus 3. Step 3, we perform polynomial division using an area model with our polynomial and one of the factors from step 2. Again, it doesn't matter which one you use, but I'm going to use the x plus 3. And then my polynomial from the other slide is down here at the bottom. Notice that I have a 0x squared here. We always have to go in order from 4 all the way down to a 0 spot. So I have x to the 4th minus x cubed. I didn't have an x squared in my original problem, so I'm going to put 0x squared plus 20x minus 48. I put x to the 4th in my starting spot, and then I toggle back and forth. So something times x on the left side times the object on the top should equal x to the 4th. So there's my x cubed. Take it times 3, I get 3x cubed. But we wanted negative 1. So something plus 3 is negative 1. So here's my negative 4x cubed. I have to figure out what times x equals negative 4x cubed. Negative 4x squared. Take it times 3. I get negative 12x squared. But we wanted 0. So to zero this out, I'm going to have to put 12x squareds over here, because 12 minus 12 is 0. Go back and calculate the top, get a 12x, take that times 3, get a 36x. But I wanted 20, so I need to take away 16 x's. Something times x is negative 16x, that's negative 16 times 3 is my negative 48, and that works out nicely. They match each other here. We don't have any remainders. So at this point, we are at 0 equals x plus 3 on the left plus the top stuff. And if I were to FOIL all of this stuff out, I would get back my original problem.